Half a day students, today we're going to be continuing section 9.3, which is about quadratic functions. For today we're going to be looking at how to use a quadratic model. So we're looking at the application of quadratic functions in real life. So for this case, for the first few cases, we're going to be talking about things that are thrown in the air. So when an object is thrown with little air resistance, its path through the air can be approximated by a parabola. So this is basically in ideal weather conditions. It's not windy, not raining. There's nothing that's going to make it slow down or anything like that. So it might look something like this. We have a ball. When it's thrown, it'll follow a path that looks something like this. Example 1, a ball was thrown and followed a path described by this equation. What was the maximum height in feet of the thrown ball? So like I said earlier, the ball is thrown, it follows a path that looks something like this, right? So we should know that the maximum height is going to occur at this spot right here, right? This, if I was looking on a graph, it would be the vertex of the parabola. So what I'm actually going to do is find the vertex, and the y value is going to show me the height, the maximum height that this ball reaches. So this distance right here from there to the parabola would be the x value of the vertex. The y value is going to be the height. But I don't have a formula for the height of the vertex, but I do know how to find the x value first of the vertex, which is going to use what we learned last time, x equals negative b over 2a. Looking at my formula, I can see that my a is equal to negative 0.02, my b is equal to 1. So I can have x is equal to negative 1 over 2 times negative 0.02. Using a calculator, I'm able to simplify this to be 1 over 0.04. Simplifying once more, we have x is equal to 25. So this x value, this is actually 25. So the x value of my vertex is 25. In order to find the y value, I'm just going to plug it into the original function. So we have y is equal to negative 0.0225 squared plus 25. Using PEMDAS, which tells me that I'm going to first evaluate my exponent and then multiply and then add this 25, I'm able to find out that y is equal to 12.5. Looking at my question again, it's asking what the maximum height in feet of the thrown ball is. I'm going to answer this in a sentence or a phrase at least. The max height of the ball is 12.5, don't forget your unit, feet. Example 2, a swim team member performs a dive from a 14-foot high springboard. The parabola below shows the path of her dive. So for this example, instead of being given an equation, I'm given a parabola that's already graphed. So what I'm going to do is just analyze this graph and see how it applies to the problem at hand, the word problem, and see how I can answer this. Looking at the first question, what is the maximum height of her dive? Once I hear max height, I know I'm going to look for the vertex, right? So the vertex of this problem is this parabola is right there. What is the maximum height of her dive? So I want to see what this height is. So it looks like it's probably around 23 feet. Okay. How far did she go before she hit the water? So I want to see now the distance from the springboard. So she jumps, she hits the water down here, right? So I want to see now what this distance is. So it starts at 0 and it goes all the way to about 8 feet, right? She hits the water at about 8 feet from the springboard. Last example, a woman in a shot put competition's throw can be modeled by this equation right here, where x is the horizontal distance in feet and y is the height in feet. So this problem actually didn't originally give the graph. I put the graph here. I actually graphed it with Desmos, which is a good tool. You can look up, just Google Desmos, Desmos. There you're able to put in the equation and then look at the graph like this. You can always zoom in or out in order to be able to see all the important points on your graph. Here I was able to click right on the edge right here, right on the very top, and right on the starting point to find my important points. So looking now at the first question, what was the maximum height in feet of the shot? So again, I'm looking at the vertex, which is going to be right here. What was the maximum height in feet of the shot? So this one, I can find it out by looking at my vertex. This y value looks like it's about 21 feet. However, I also know that I can find it algebraically. So if I want to do that, I'll find the x value of the vertex and use that to find the y value. We'll just practice it here again. So I can see x is equal to negative b over 2a. So since my b is 0.9325, I have negative 0.9325 divided by 2 times 0.01347. Simplifying this using a calculator, I'm able to see that this is approximately, let me use approximation symbol instead, is approximately 34.61. From there, I'm able to plug it into the original equation. Y is equal to that. Instead of x, I'm going to put in 34.61. And using the calculator, I can find out that y is approximately 21.6. So whenever you're unable to determine it exactly using the graph, you can always find your max height algebraically, and that's if you're given an equation. So what is the maximum height? Max height is 21.6 feet. What was the distance of the throw to the nearest hundredth of a foot? At this point, we're not able to find it algebraically yet. We'll find out later this section. But the distance of the throw to the nearest hundredth of a foot, I know when it finally stops is the point when it hits the ground, right? So I want to see, what is this x value? What is this total distance that it traveled? It looks like if I was to put the thing there, I can say, okay, it's 74.694 feet. So we can say about 74.6 feet. That's it for now. Please, when you're doing your seat work, don't just guess. Try to actually look at the graphs and analyze them and see how you can find the correct answers. Be sure to keep in mind whether or not things are measured in the thousands and the hundredths, and also be sure to write a unit whenever you're answering a problem. And when a graph is not available, when it's not given to you, you can always use your tools online to help you graph, because this is something that's a little bit hard to graph if you don't have graphing paper, and even so it still can be difficult. So you can use Desmos and any online graphing tool to try to help you determine the necessary values for the problems. Good luck!